State the law of conservation of momentum. When two or more bodies act on one another, their total momentum remains constant, provided no external forces are acting. Discuss the law of conservation of momentum in each of the following cases. Rocket taking off from the ground. Before launch, the rocket is at rest, hence the total momentum is zero. During the launch, a large amount of gases are burnt and they are pushed or they move in the downward direction. So this momentum is in the downward direction. Say it is plus P. Now the total momentum before impact should be also equal to momentum after impact. So in order to balance or to make the momentum after impact also zero, the rocket moves in the forward direction and produces a negative momentum upwards. Now the total momentum is zero. This can be explained in accordance to the law of conservation of momentum. The chemicals inside the rocket burn and produce high velocity blast of hot gases. These gases pass out through the tail nozzle in the downward direction. The rocket moves upwards to balance the momentum of the gases to make the total momentum zero, because before impact the momentum was zero, so after impact also the momentum should be zero. Before launch, the total momentum of the system is zero. In order to keep the momentum zero, the rocket moves upwards, producing an equal and opposite momentum to that of the gases. The same case in the will be in the jet aeroplane. In a jet aeroplane, the gases move in the backward direction, and hence there is an equal and opposite momentum created in the forward direction that pushes the jet forward. A 60-gram bullet fired from a 5 kg gun leaves with a speed of 500 meters per second. Find the speed and velocity with which the gun recoils or jerks backwards. So we have two quantities here. We have the bullet. Let the mass of the bullet says m1 and its velocity, final velocity is v1, and then we have the gun, mass m2, final velocity v2. Now we do not write the initial velocity because before firing both are at zero, at rest. Okay, then maybe we can write it. Before u1 0 meter per second, and here v1 will be 0 meter per second. For the bullet, the mass is 60 gram, but we have to convert it into kgs, and the speed is given 500. For the gun, it is 5 kgs here, and we have to find its recoil velocity. We'll put it x. According to the law of conservation of momentum, m1u1, m2u2, total momentum before impact equal to total momentum after impact. So now we go ahead and substitute. Here we know m1 is 60 over 1000, that's of the bullet. u1 0 because it's at rest before impact. Gun is 5, it's also at rest before impact. Now m2 is 5 of the gun, v2 we need to find, we put it x. m1 is of the bullet, so 60 over 1000 into 500. Now this is before impact, bullet in the gun at rest, so it's 0. So this is 5x plus 1, 2, 1, 2, and we cancel. So this is 5x plus 30. 5x equal to minus 30. X equal to minus 6 meter per second. Now why did we get negative? Because if the bullet is in the forward direction, moving in the forward direction with a speed of 500 meter per second. The gun will definitely move in the backward direction with a speed of 6 meter per second, and hence a negative sign to show that it recoils. It goes in a direction opposite to that of the bullet. A 10-gram bullet. Now here again we have a bullet. A 10 grams, so the mass is 10 over 1000. Remember, we have to work in kg. Traveling at a speed of 200 meter per second. So initial velocity 200 meter per second. Strikes and remains embedded in a 2 kg target. So the bullet hits the target. The mass of the target is 2 kg, which is originally at rest, which means U1, U2, original initial velocity of the target is it's at rest, so 0 meter per second. At what speed does the target move off? So we have to find the final velocity of the target. We'll say it is x. Now remember, the bullet will get into the target and both of them will move together. So the final velocity of the bullet will also be x, because the bullet gets into the target and both of them move together. Now the law of conservation of momentum, m1 u1 m2 u2 equal to m1 v1 m2 v2. M1 10 over 1000. Here I put up the bullet 10 over 1000. U1 of the bullet is 200. And then when it comes to the target, the mass of the target is 2, but the target was at rest, so initial velocity is 0, equal to, now M1 is the bullet, so 10 over 1000. The final velocity of the bullet is x, plus the mass of the target is 2, and the final velocity of the target is also x, because both the bullet and the target move together. So we go ahead and solve this. 1, 2, 1, 2, we cancel. So this becomes 2. 2 into 0 is 0. 1 here we cancel out. So we get x over 100 plus 2x. So we get 2 equal to 102 x over 100. We cross multiply. I'll just do it in the same slide. So I have 200 equal to, just do that again. So I have 2 equal to, LCM is 100, so this is x plus 200x. So 2 into 100 is 200 equal to 201 x. So x equal to 200 over 201 meter per second, and that answer x, I think, works out somewhere close to 0.99 meter per second. So the bullet and the target move together with a velocity of 0.99 meter per second. A ball x of mass 1 kg. So here I have two objects. One is a ball x. The mass, I'll call it m1, which is 1 kg, traveling at 2 meter per second. So u1, 2 meter per second, has a head-on collision with another ball y, identical ball y. So for ball y, the mass m2 is identical, so it will be 1 kg. At rest, so y was at rest, so initial velocity of y is 0 meter per second because it's at rest. Then after collision, x stops, so v1 equal to 0 because it stops. and y moves. So v2 say equal to x meter per second. Calculate the velocity of y after collision. Law of conservation of momentum. m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Now we put the values 1 into 2 plus for ball y 1 into 0 because it was at rest, initial velocity was rest. After collision 1, the ball x stops, v1 is 0 plus m2 that is 2, and we have to find the final velocity. So we have 2 plus this is 0 equal to 0 plus 2x. So 2 equal to 2x. Here m1 is 1, it should be 1x. So this is now 1x. Hence here is 1x. So x equal to 2 meter per second. So y will then move with a speed of 2 meter per second. A boy of mass 50 kg. So here we have a boy. Mass m1 of the boy is 50 kg. Running at 5 meter per second. So velocity, initial velocity 5 meter per second. Jumps on a trolley. So the other object is a trolley of mass 20 kg. So m2 is 20 kg. Traveling in the same direction at 1.5 meter per second. So the trolley also is moving with a velocity of 1.5 meter per second. What is their common velocity? So when the boy jumps over the trolley, then both move with the same velocity. So we put here x meter per second, and that of final velocity of the trolley will also be x meter per second. Law of conservation of momentum. m1 u1 plus m2 v2 u2 equal to m1 v1 plus m2 v2. Now to put the values, 50 into 5 plus, here I have 20 into 1.5 is equal to m1 of the boy, final momentum of the boy 50, final velocity we do not know, it's x, and the final momentum of the trolley 20 into x. Both is xx because the trolley and the boy are moving together. So we have 250 plus this is 30, 50x plus 20x. So this will turn 70x. When you add this, you get 280. So x is 280 over 70. X is 4 meter per second. So the common velocity of the boy and the trolley is 4 meter per second. A girl of mass 50 kgs. However, the picture here is I put of boy. So I'll just write here girl. Her mass is 50 kg. Jumps out of a rowing boat of mass 300 kg. So on the other side we have the boat, and the mass of the boat is 300 kg. Onto the bar with a horizontal velocity of 3 meter per second. So the velocity, final velocity is 3 meter per second. Why final velocity? The initial velocity will be 0 because first the men here and the boat were at rest. So the initial velocity was 0. Even of the boat, the initial velocity was 0 meter per second. Now when the men moves in the forward direction, there's a momentum in the forward direction. Hence there will be an equal and opposite momentum in the opposite direction. So here we have to find the final velocity of the boat. We call it x. So according to the law of conservation of momentum, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Now here I won't even put the values. I'm just putting 0 here because the boat and the men initially were both at rest. So the total momentum is 0. But now the girl moves forward, so it will be 50 into 3 plus for the boat was 300 into x. So 0 equal to 150 plus 300x minus 150 equal to 300x. So x is minus 150 over 300 and x equal to minus half meter per second. Now why did the negative sign come? The men move forward with a speed of plus 3 meter per second. To keep the momentum 0, the boat had to move backward with an equal and opposite momentum, and as the boat has to move backward, its velocity has to be taken negative, half meter per second. Remember, the forward momentum of the men is equal and opposite to the backward momentum of the boat, so that the total momentum becomes 0. Before impact, the boat and the men were at rest, total momentum was 0, and after impact also the momentum has to be 0. A truck of mass 500 kg. So we have truck 1 and the mass of the truck is 500 kg moving at 4 meter per second. So initial velocity 4 meter per second. Collides with another truck. So we have another truck here, say 2, and with a mass of 1500 kgs. Moving in the same direction at 2 meter per second. So initial velocity 2 meter per second. What is their common velocity after collision? So both of them, common velocity means they move together. So v1 I'll put x meter per second, and here we have v2 x meter per second. According to the law of conservation of momentum, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. For the first truck, initial momentum is 500 mass into velocity, plus of the second truck, the momentum is mass 1500 into 2, initial momentum. Final momentum of the first truck is 500 into x, because we do not know the final velocity, and of the second truck it will be 1500 into x. We go ahead and work this out. Here we multiply, so this becomes 30 0 0. When you add this up, here you get 2000 x. I put 200, that's wrong. So it is 1500 plus 500, 2000 x. So here we get 50,000 equal to 2000 x. Here again, this is not 50,000, this is 5,000. So it becomes 5,000 over 2000 equal to x. 2.5 meter per second equal to x. So both the trucks will move together with a speed of 2.5 meter per second. The velocity of a body of mass 10 kgs. So m equal to 10 kgs increases from 4 meter per second, that is u, to 8 meter per second. So u is 4 meter per second, v 8 meter per second. When a force x on it in 2 seconds, so time equal to 2 seconds. What is the momentum before the force x? So the initial momentum A. So initial momentum, we call it P1, is mass into initial velocity. So mass 10, initial velocity 4, so initial momentum will be 40 kg meter per second. Then next, what is the momentum after the force x on it? So that is a final momentum. So final momentum we call it P2, will be mass into final velocity, that is v. So 10 into v is 8, so this is 80 kg meter per second. What is the gain in momentum? The third is gain in momentum is a difference in momentum, and that will be P2 minus P1. So 80 minus 40, 40 kg meter per second. This is gain in momentum. They are asking gain of momentum per second. So this gain in momentum is for 2 seconds because the time was 2 seconds. Therefore, gain in momentum for 1 second will be 40 over 2, and that is 20 kg meter per second. And here they are asking you what is the value of the force. We know force equal to m into acceleration. So m acceleration is v minus u over t. So mass is 10, v was 8, then minus 4, and over it was 2, time was 2. So 10 into 4 over 2, and then if you cancel this, this becomes 20 newtons. And you would have now noticed that gain in momentum per second is equal to force, because both the values come 20 newtons. A gun of mass 3 kg. So we write the gun. Mass of gun, say M1, is 3 kg. Fires a bullet of mass 30 grams. So on this side we have the bullet, and the mass of the bullet, we call it M2, is 30 gram, but 30 gram will make over 1000 kg. The bullet takes 0.003 seconds to move through the barrel of the gun and acquires a velocity of 100 meter per second. So this is velocity of the bullet, V2. Remember, U1 is 0 because they are at rest. So 100 meter per second. U2, the initial velocity is 0 because before impact or before firing, the gun and the bullet are at rest. We need to find the recoil velocity of the gun. So we need to find V1 is x, recoil velocity, and U1 for the gun is also 0 meter per second. I repeat again, the total momentum of the gun and the bullet before firing is 0 because both are at rest. According to law of conservation of momentum, M1, U1, M2, U2 equal to m1 v1 plus m2 v2. Now when we are solving the sum, I won't even calculate before impact because it is 0. The total momentum before impact is 0 since both are in rest. So here this is of the gun into x, which we don't know the velocity of the bullet, mass of the bullet into velocity of the bullet. So we have 0 equal to 3x, 1 2 1 2 and this cancels, plus 3. So we have x equal to minus 1 meter per second. Why did we get a negative? Because when the bullet is moving in the forward direction with a speed of plus 100 meter per second, the gun is moving in the backward direction with a velocity of 1 meter per second. So if the forward direction is taken positive, the backward should be taken as negative. For the next part, we have to find the force exerted by the gunman due to recoil of the gun. So for the gun alone, I'll do it here. We know the mass is 3 kg. The initial velocity of the gun was 0 because it was at rest. Then it recoiled with a velocity of 1 meter per second. And all this happened in a time of 0.003 second. So to calculate the force, we know force equal to mass into acceleration. Mass and acceleration is v minus u over t. Mass is 3. v1 minus 0 over time is 0.003. On doing this calculation, you'll get the answer 1000 newtons. So the gunman exerts a force of 1000 newtons to stop the recoil of the gun, which means the bullet also is moved forward with a force of 1000 newton. Let me explain this point. Here the bullet moves forward with a force of 1000 newtons. By Newton's third law, there will be a backward force also of 1000 newtons exerted on the gun.